Hi everyone, today we're going to talk about transformations of the cubic parent function. So today we're really just going to focus on the cubic function. Tomorrow we'll talk about the cube root transformations, but today we're just going to focus on the one that you see in the graph here. Remember that those key points for the cubic parent function are kind of like at -1, -1, 0, 0, 1, 1, and then we also have points at 2, 8, and -2, -8, but we know that that's not where these graphs stop and that they do continue on and on until infinity in both directions. So we have the parent function that's right here for you, f of x equals x cubed. And with our transformations, this is the format. And so you might want to take a highlighter, not an eraser, Miss Belsick, a highlighter, there we go. You might want to take a highlighter and highlight this, because this is where the transformations show up in the equations. Now, a lot of times, you're going to end up with something in a problem that looks like this, or like this, or like this, or like this, and that really doesn't help you figure out where these changes go because it has an F and parentheses in there. And so what I really want to start off the class talking about is how to change a problem that maybe says like f of x minus 3 to something that actually looks like you're making a change. So we would change this to f of x equals x minus 3 in parentheses cubed. And that way you could actually type something like this into Desmos and you can get an answer versus typing in f of x minus 3. That won't really give you much of anything in Desmos. So the trick is, and there are two of them, the trick is that anything in parentheses, cube it. It's what goes along with x. So if you have something that's in the parentheses, then that means that it's going to be something that's getting cubed. So that's a trick. If you have f of x plus something or x minus something, then that x plus or minus something is going to be cubed. Now if you have, this is the second trick, if you have anything outside of parentheses, then write it outside of parentheses. Write it in front of or behind x cubed. Write it in front of or behind x cubed. So if you have a problem that asks you to write an equation where the function f of x, the parent function f of x plus 5 is, if you want to show that function, well, that means that you need to add 5 after the x cubed. So you would have f of x equals x cubed plus 5. So this is just kind of a general way to figure out how to rewrite your functions whenever they're given to you in something that looks like this versus something that you feel like you can understand more. So these bottom questions on here, we'll come back to these. We're not going to do them right now. There are transformations that are happening from the cubic parent function to these graphs, but we're not quite ready to write down those functions yet. Now I do want to talk about maybe the domain and the range here. Let's talk about that part first, and then we'll come back and we'll add in the equations a little bit later on. So in graph A, we've got this point. This point is right in the middle. What would you call that? The what of the graph? The vertex. So the vertex here isn't at 0, 0, it's somewhere else. And we know that the ends of this graph truly do go down and up forever until infinity in both directions. So can you put boundaries on the left and the right side? No. So your domain is all real numbers. Can you put boundaries on the bottom and the top for the range? No, because we've got arrows. So the range is also all real numbers. Let's talk about example 1b. Here's my vertex. I know that the graph extends in both directions. There's no boundaries on the left side or the right side, so my domain is all real numbers. There's no boundaries on the bottom or the top, so my range is all real numbers. So unless you have some kind of interval that you are restricting, then your domain and range are going to be all real numbers because there's nothing that's going to stop those arrows. So let's go on to the next page. We start out talking about reflections. So we've talked about reflections before. Anytime you have a negative somewhere, that indicates a reflection is happening. If you have a negative outside of parentheses, that's a vertical reflection. And when you reflect vertically, you're taking something and you're reflecting it over the x-axis. So if you have a negative outside, you are reflecting your parent function over the x-axis. Now, if you have a negative inside of parentheses, that means that you're doing a horizontal reflection. So a horizontal reflection means you're taking something on the left, putting it on the right, something on the right, putting it on the left, and that's a reflection across the y-axis. So you're reflecting your parent function across the y-axis. So outside, vertical, inside, horizontal. If you can remember that, then you can get your reflections straight. Example 2 asks for you to graph each transformed cubic function. So if I graph each transformed cubic function, I do want to remember the order that I'm supposed to translate in, and perhaps you remember from long time ago, B, H, A, K. B, H, A, K. So stuff inside of the parentheses first, stuff outside the parentheses second. So I'm going to shift 2 units. 2 units in what direction? I'm going to take my parent function and I'm going to shift it 2 units to the left. So here's my original parent function points. And I'm going to change colors here. I'm going to shift this 2 units to the left. So everything gets shifted over 2 units. So that takes care of my shift to the left. And then finally, I have this negative right here, and it's outside of the parentheses, so that means it's vertical. A vertical reflection means I'm changing things up and down. That means that I am reflecting over the x-axis here. So any purple point that I have, I'm going to count to the x-axis and then past the x-axis. So this point, I count down 8, count down 8 more. This point, I count down 1, and I count down 1 more. This point is on the axis. Its reflection is still on the axis. This point, I count up 1 and up 1 more. And this point, I count up 8 and I count up 8 more. So this set of red points right here, this is my transformed function. I didn't restrict a domain or a range, so my domain and range are still all real numbers. Let's look at example 2b. Anything inside parentheses I do first, so I notice that if I have my original parent function points, which you might want to start off all your problems by graphing, you've got a reflection here. That reflection is inside with x, that means it's horizontal. So that means that everything that's on the right side of y, you're going to flip it over to the left side. And anything that's on the left side, you're going to flip it over to the right side. So 1, 2, 1, 2, 1, 1, on the axis, 1, 1, 1, 2, 1, 2. So there's my reflection. We got that. And then the final transformation that needs to happen, the K transformation, is I need to subtract 2. So I need to go down 2 units. So I'm going to go down 2 units. 1, 2, 1, 2, 1, 2, 1, 2. And then here I kind of get to estimate 1, 2. So this is my new transformed function. I'm not restricting my domain or range, so I'm still going from infinity to infinity. In both cases, my domain is all real numbers. So let's look at scale changes, stretching, compressing. There was an easier way that we found how to determine scale changes. And the way we did that is we counted, with parabolas at least, we counted going to the right 1 unit and how many units you go up. You should be going up 1 unit, but if you went up more, then that was your scale factor that you were changing. So example 3 has 2 problems, and they both have scale changes. Both of those scale changes are not in parentheses, so since they're not in parentheses, they're vertical. This one is a big number. It's a vertical stretch because it's a larger number than 1. So what I'm going to do is, instead of my y values being x cubed, like -8, -1, 0, 1, and 8, my y values are now going to be 2 times x cubed. So I'm going to multiply all of these by 2. I'm going to stretch them all vertically. So my new y values are -16, and -2, and still 0, and 2, and 16. So I'm going to take 2 times my x cubed values, and that gives me the y's. So instead of my original points, I have my new points. So -2, -16 can't be graphed, but -1, -2 can, and 0, 0, and 1, 2, and 2, 16 can't be graphed, but we know that it's way far down there. So it has been stretched vertically. Now the second problem, the 1/2 that's being multiplied is also not in parentheses, so it's not a horizontal change, it's vertical. Because it's a small number, between 0 and 1, we say it's a vertical compression. So it's almost as if your graph is going to vertically flatten a little bit. Now, instead of your original y values of -8, -1, 0, 1, 8, we're going to take these y values and we're going to multiply them by 1/2. So we're going to cut them in half. My new y values are -4 and -1/2. Half of 0 is just 0. +1/2 and 4. We're taking all of them and we're cutting them in half. So what was my original cubic function, my parent function, ends up compressing a little bit vertically. So -2, -4, -1, -1/2, 0, 0, 1, 1/2, and 2, 4. So we end up with something that looks a little bit fatter. So this is what it looks like to have a vertical stretch. Notice, and I'm going to do this in kind of an obnoxious blue color, notice that instead of going from the vertex over 1 up 1, like you should in the parent function, here we go over 1 up 2. That a value is 2. Same thing here. Instead of going over 1 up 1, you go over 1 up 1/2. And so that means that a is equal to 1/2. So that kind of ties together those stretches and compressions, those scale changes from quadratic functions into functions that are cubic like this. Now the last thing that we have is a set of problems. It says, given the parent function, the cubic parent function, f of x equals x cubed, write the equation for the given transformation and then describe the transformation. So anything inside the parentheses, you need to cube it. Anything outside the parentheses, you write before and after x cubed. So there's nothing in parentheses with x. So nothing else gets cubed except for x. There is a 2 multiplying in front though, and a +3 on the end. So we've rewritten this in a way that a graphing calculator might be able to see it. There's no negatives, so there's no reflections. Translations, there is some adding and subtracting. If I have +3 at the end, that means that I'm shifting up 3 units. So I'm going to say up 3. Scale changes, am I multiplying by anything? Yes, I am. I've got a 2 outside parentheses, so that means it's vertical. And since it's bigger than 1, it's a stretch. And it's by 2. My domain, I didn't restrict, so it's still all real numbers. My range, I didn't restrict, so it's still all real numbers. What I'd like for you to do is pause your video and try the next problem. Try to rewrite the equation, try to answer about the transformations. Check back for my work. Outside of the parentheses, we had a negative in front, so we have a negative in front here. That gives us a reflection over the x-axis. And then inside the parentheses, we had x plus 4, so that's what's getting cubed here. And that's a shift to the left 4. There's no scale changes because we're not multiplying by anything. The domain and range are still all real numbers. So let's take a look at these last 2 problems. They are a little strange. I can rewrite them pretty easily though. I have this inside, so this is what's getting cubed. And then I have the +5 outside, so that's what's getting added on outside. However, when I go to figure out what transformations are occurring, I can't have negative x without some parentheses in between it. So if you remember correctly, we had to divide this by whatever was out in front. So what we really end up with is -1 times x minus 3. So if you have a negative out here, that's great. That gives you the reflection. The reflection is inside parentheses, so that means that it's horizontal. It's going over the y-axis. Translations, we are shifting down 5. We are also shifting to the right 3. And if we hadn't done this work in the beginning and moving that negative outside of parentheses, then we would have gotten this wrong and we would have said it shifted to the left 3, but it doesn't. It shifts to the right 3. There is no scale changes. We're not multiplying by anything other than the -1, and the domain and range are not restricted. And finally, our last problem today, what's inside parentheses gets cubed. What's outside gets added onto the outside. I don't want the 3 and the x together. The 3 has to be separated, so I have to divide by 3. That means the 3 comes out. I have x minus 2, because 6 divided by 3 is 2 cubed. And then minus 8. Are there any negatives? No. So there's no reflections. Is there any plus or minus numbers? Yes. We're shifting down 8. We're also shifting right 2. Scale changes, we have a 3 in parentheses. So that means that this is a horizontal change. It's a big number, but anything in parentheses is a lie. So instead of stretching with the big number, we compress. And we compress by the reciprocal of 3. Well, the reciprocal of 3 is 1/3. So we're compressing by a factor of 1/3. We didn't restrict the domain. We didn't restrict the range.